Welcome back, guys. This is still 3.2. In this video, we are going to solve problems using parallel line theorems, the theorems that we talked about in the last video. So make sure you watch that last video to understand these theorems about congruency and supplementary angles, because we are going to use them in order to solve diagrams, complete angle measures in diagrams, okay? So let's get started here. When we have a diagram and we're solving, it's so important, guys, that we label our diagram. It helps you so much. So in this one, it says, if measure of angle 2 is 110 degrees, find the measures of all the other angles. All of those, look at, we have 8 angles in this diagram. How am I going to do that? I need to use the theorems and the postulates that we've studied, okay? So when I look at this, the first thing I think of automatically is it's my favorite one. My favorite theorem is vertical angles, okay? I know vertical angles are congruent. So I see angle 2, and right away I want to say now angle 3 is 110 degrees, and that's true, okay? Next thing I want to do is I want to remember corresponding angles. What do I know about corresponding angles? Corresponding angles are congruent. So what can I say about angle 6? Also 110, right? Let's label that. The reason I can say all of this is because I have parallel lines cut by that transversal. So I can make these statements about these angles being congruent, okay? Well, if angle 6 has a vertical angle of angle 7, well, I know angle 7 is also 110. This is going way faster than I bet you thought it would. Now, how am I going to figure out the angle measures of 1, 4, 5, and 8? What do we think? Well, check out, I have a line here, right? I have kind of supplementary angles, don't you think? Right? Angle 1, it's a linear pair. Angle 1 and angle 2, they're supplementary. So how am I going to find angle 1? I can do 180 minus 110. I'll get 70, right? 70 is measure of angle 1. How am I going to find angle 4? Vertical angles, right? Vertical angles tells me angle 4 is also 70. How am I going to find 5? Corresponding, right? Corresponds to angle 1, so this is 70. And vertical angles 5 and 8 tells me 8 is 70. Okay, guys, so how did we do this? What theorems, postulates, definitions? The vertical angle theorem, corresponding angles postulate, and supplementary angles allowed me to solve for all 8 of those angles. Isn't that crazy? I only knew 1, right? But just with that one, I was able to identify all 8 using these theorems, postulates, and definitions. Okay, it all ties together. Let's practice another type of example. Check out this one. What are the values of x and y? Notice I have x variable and a y variable. It's difficult in this diagram to find my parallel lines and my transversal. So for what I'm going to do, because right now this kind of looks like a polygon, right, doesn't it? I want to extend these parallel lines. I know these are my 2 parallel lines because they're noted, right? See those little red arrows? Let's do x first. And I'm going to trace over and extend that transversal. Now it is way easier for me to identify my special angle pairs because I'm just focusing on these intersections. What special angle pair is this angle and this angle? Well, I want to think about it. Are they on the interior or the exterior? They're on the interior, right? And are they on the same side or opposite side of my transversal? Same side. So I can confidently say that this I would be using the consecutive interior angle theorem. Well, what does that tell me? Consecutive interior angle theorem tells me that angles add up to 180. They're supplementary. Okay, and that's what I'm going to use. Consecutive interior angles theorem. That theorem to solve for x. So I can write equations. I can say 2x plus x minus 12 equals 180, right? This angle plus this angle are supplementary, so we can add them together to get 180. I'm going to combine like terms. This comes down to some good old algebra. 3x minus 12 equals 180. I'm going to add 12 to both sides. I'm going to get 192. And I'm going to divide both sides by 3. And I'm going to get x equals 64. Okay? Solve for x. We're good. Right? Bring any questions. I want to say, any questions for me? Okay? I can do the very similar process for this guy over here. Right? Aren't 3y and y plus 20, aren't they also consecutive interior angles? Interior of my two parallel lines, consecutive on the same side of the transversal. So I can set up that equation. 3y plus y plus 20 equals 180 because they are supplementary angles. Consecutive interior angles are supplementary. So I'm going to combine like terms. 4y plus 20 equals 180. Solve for y. I'll subtract 20 from both sides. I'm going to get 160. Divide by 4 on both sides. I'm going to get y equals 40. Solved for my variables. Now it wants me to find the measures of the 4 angles. Well, how am I going to do that? I now know what x is, so I can substitute x into that expression. So I'm going to say 2 times my 64 gives me 128. So this angle right here is 128 degrees. How am I going to find this one? Well, there's a few ways, right? We could put x in. We could substitute x in. Another way we can do is subtract it from 180, right? 180 minus 128 because I know they're supplementary. And I'm going to get this angle is 52 degrees. Similarly, I'm going to do it for the other consecutive interior angles. Substitute y in to find this angle, and I subtracted it from 180 because they're supplementary. Okay, guys? Great work. Another example we are going to practice is this one. We want to find the values of angles 1 and angle 2. Again, they want us to find this angle over here and this angle right here, and all they're giving me is the 60 and the 65. What? Are they crazy? What we want to do is focus at one thing at a time. First of all, I want to make sure I can see my parallel lines. I'm going to highlight those parallel lines. Check these guys out. They're hard to see. And which one do we want to do first? Let's do angle 1. So what I'm going to do is just focus on this transversal. I'm going to completely ignore this other transversal that's happening in here. Okay? So what we're going to do is I'm going to try to find the relationship between angle 60 and angle 1. Okay? And what I notice is they're both on the interior of these parallel lines, and they're on opposite sides of my transversal. So what can we say they are? They are alternate interior angles. Okay? Another way, remember I taught you that Z trick, right? If it makes a Z, they are congruent, and they are alternate interior angles. So now I can say measure of angle 1 equals 60 degrees. Okay? Wonderful. What we're going to do now is find measure of angle 2. And what we're going to do is look at now that other transversal. Okay? This other transversal here. And I can look at alternate interior angles again, right? And when I see that, let's highlight those alternate interior angles. And it's going to be right here. Let's find my parallel lines. We're going to go this one, and this one. See that? We'll go, here's my alternate interior angles. So now I'm working with the 65 and this angle, right? So now I know that this angle is 65. So how am I going to find the measure of angle 2? Okay, I'm going to do 180 minus 65 because that's going to give me the measure of angle 2 is 115 degrees. All from using the alternate interior angles theorem. Okay, guys, it all comes together. Great work. You guys rock.